Yeah, welcome everyone. Today's most talks are about some specific products about security, but mine will be a bit different. It's about how you can build up your security around your Kubernetes clusters. So I will talk about lots of different stuff. Um, my name is Koray. I work for Kubermatic. As the old company, we all work remotely. I'm working from Istanbul. I'm Kubernetes consultant. I'm also instructor for our trainings. Yeah, I have some certificates and those stuff. So imagine this is your one of your colleagues. Uh, he he finishes all his tasks on Jira, depending on its description. He's a well-performant team player, and the management loves him. But one day, when he comes to the office or from home, when he opens his laptop, he comes up with those kind of news about his company have some security issues, and now the management does not like him anymore. No one likes him. You or any of your colleagues should not be that person. You should take care of the security. I mean, it's a serious issue. And also, it is hard for security people as well to make sure that all the rules within the company are followed. They need to be they need to be as solid as a rock, because if you're a developer or towards your end of sprint, or when you're about to make a new release, a guy comes in and says that, hey, there are some vulnerabilities, you need to triage or you need to fix them, etc. It's not an easy job, and let's face it, we don't like those people, right? It's like maybe not those persons, but their job, and it's also hard for them to do it. But we all have to take it serious. If you look at Shodan or some other sites, you will see that there are lots of Kubernetes clusters. There are unsecure Kubernetes clusters, and it just without authentication enabled, or not enough firewall configurations, etc. I will quickly talk about Kubernetes architecture to be on the same page. I know I mean, you all know about it. But we have the control plane and the worker nodes. And on control plane side, we have etcd, API server, cloud control manager, scheduler, and control manager for other stuff. And on the worker side, we have the container runtime, kubelet, and kubeproxy. And what happens is that API server is the only one component talking to etcd. etcd is our database for all configuration. And the other control plane components talk to the API server to access the data on etcd. Also, API server communicates with kubeproxy and kubelet on the worker nodes, and kubelet communicates with the container runtime to make sure that the containers are running, or it gets the logs or other information about your containers or your pods. And as the user, developer, or admin, you are directly communicating with the API server. You know, etcd is not part of the Kubernetes project. It's a separate database. By default, I think everyone deploys it on the control plane side, but it can be also deployed externally as well. So this is more realistic picture with multiple control plane nodes and multiple worker nodes, and you see there are a lot of communication between different virtual machines or real bare metal machines, or however your environment is. And between the worker nodes, we have the CNI plugin, Container Network Interface plugin, to make sure that all pods can communicate with each other within your Kubernetes cluster. So after this recap, I will talk about a Greek mythology. This is a real one, as you see from the fonts. It's from Greece. King Admin the naive becoming the King Admin proactive, and we will be see how he takes care of things. So this is King Admin. He's a wise king. He's a bit naive, but he knows that he needs to protect his land. He wants to be more proactive and make some decisions or take some actions to secure his Kubopolis. So this is Kubopolis. King Admin is there. You can call it King's Landing. And there are also some suburbs around it to make sure that the farming or the blacksmith and the other people are doing their jobs. So yeah, these are the part on the on his landing, King's Landing, and Kubelet, kubeproxy, and container runtime agent are the ones on the suburbs. And as of any other story, we have the villain. He is called Hakarios. Of course, he will be trying to take down his kingdom and attacks everywhere. So the first thing we do for security in general, it's not specific to Kubernetes, but we put firewalls around our cities or around our servers, right? So when Hakarios wants to attack anywhere, we have those walls around it. But even we have the walls, I mean, with the real cities, we have some gates or ports that let people or some other stuff to come in and out. But the important part is that you want to know who comes in and who comes out. So if so hackers should not get inside from those gates. These are the default Kubernetes control plane ports for API server, etcd, kubelet, scheduler, and control manager. Well, at least these should not be open to the whole internet. This should not be public, if that's possible. And these are the known, default worker node ports, 10 to 154 kubelet and 30,000 to 32,767 for the default range of node port servers. So you should make sure that you have some firewalls around those ports. So now we have the firewalls around the cities, the green ones. Hakarios cannot attack now. But he decides to attack the suburbs, and we need to secure the worker nodes. So, well, on the worker nodes, the component that acts as a server or as an API is kubelet. And kubelet is responsible for getting the pod specs from API server, from etcd through API server. It fetches the logs for pods and send it to API server when you run kubectl log command, for example. When you do kubectl exec, it goes through kubelet as well. And when you do kubectl port forward, again, kubelet is used. So there is some communication between this. And there should be a, it should be protected somehow. We should make sure that only kube API server is communicating with kubelet, but no one else. So Hakarios also wants to do so this time it tries an identity theft. We should restrict the permissions to users or service accounts and applications. So on the container runtime, well, he can try to do some stuff around container runtime or around the pods. So the question is, even if you do not specify a service account on your pod specification, um, is there a service account inside or defined by default? And well, the answer is yes. There is a default service account per each namespace, and the token of it is mounted by default to all pods. So what you need to do, if you will, so this is needed if your pod will be talking to Kube API server to get some info. That's why we use service accounts. And if your pod will not use it at all, then you don't need to mount it again. So auto-mount service account token should be false to make sure that you will not have this default service account token mounted to your pods. For the Kubernetes, I think with the current installations like kubeadm or any cloud provider installations, I think the RBAC is coming by default, and you probably don't need to do any extra configuration, but you have to make sure that role-based access controls are configured, and I think it's already told previously that it should be based on you should give the permissions to people who needs to do what, so they shouldn't have some extra stuff. Yeah, this is, I think again, this is with kubeadm or others, this is there, but you should also check the authorization mode. It should be node and RBAC at least, but it would be nice to check it. And for RBAC, we have the two things. It's a cluster role which is valid for the whole cluster, or a role which is valid for a specific namespace. So it could be something like to get list or watch pods or create secrets, delete config maps, whatever, a role. You can have a user and a service account, and you have the binding to make sure that those roles are bound to those users or service accounts. So when you have those, you also have more secure container runtime environment, let's say. And then, well, Hackerius is also smart, and he wants to attack the messengers. So there are a lot of communication going between different components of the Kubernetes cluster. So we should make sure that these are encrypted, especially at usage, transport, and rest. So when I say, what do I mean with usage, transport, and rest? So there is, with transport, it could be from pod-to-pod communication or from API server to kubeproxy or kubelet configuration. It could be at usage within your pods, or it could be at rest in etcd. So we should also make sure that these are also safe. So encryption at usage is, well, the first thing is on your GitHub repos, or whatever, not necessarily GitHub, but in your Git repos. You should not put your secrets as unencrypted you shouldn't push them. I think on the first presentation we saw it already. They should be at least encrypted, or should not be at Git at all. And Kubernetes secrets, well, the name is nice, but unfortunately they are not really secrets. Maybe you know this Stack Overflow reply. The idea was to have secrets encrypted, but that never happened. So they are all base 64 encoded, and well, it's good that the config maps and secrets are different objects, so that with RBAC you can make different roles and bind them, but still Kubernetes secrets are not secrets. And another good part is that they are mounted as TMPFS to a pod, so they are not actually written to a hard drive, which is a more, it's a better implementation. and when they are mounted in a pod, they are actually decoded as well. But yeah, basics for decode is also quite easy thing to do. So you can, of course, use secrets, but make sure that they are not, how do you say, put unencrypted, at least on your Git repos. The transportation part is mostly covered by Kubernetes itself. So as you know, it's between API server and the other components, the communication is already SSL. So, of course, it can be, if you have enough time and enough resources, you can break it, but I think it doesn't worth to try that out. But the thing is between pod-to-pod communication, that is by default like HTTP if you do not implement any stuff. You can implement things on your own, on your applications. You can just make sure that your application is running with SSL, which is hard to do. This was the case in the past, before maybe Kubernetes or before sidecars and stuff, but I think no one does this anymore. And instead, people use service meshes. With the Istio or Linkerd, when you install those service meshes inside your Kubernetes cluster, basically you have a new sidecar container within your pod, which takes care of this MTLS, mutual TLS communication between different applications. I think you should have this thing. In the afternoon, there will be another talk from Isovalent about Cilium. Cilium also takes care of this without sidecars. Not necessarily you don't have to use a sidecar proxy. You can use some other solutions as well. But it is a good practice to have TLS communication or SSL communication between your application within your cluster. Well, basically, yeah, for Istio control plane takes care of the whole certificate lifecycle, and MTLS is the default for Istio. So you took care of the transportation part as well, but what about encryption at rest? Here, when I say rest, it's etcd. So by default, your secrets are not stored as encrypted inside etcd. So when you get an etcd dump, your secrets will also be unencrypted there inside your dump. You can have an encryption configuration for your API server saying that those resources should be encrypted with this key. So you can put secrets. You can also put your you can also say that, okay, I want to encrypt my config maps, but I don't know if it is really necessary, but at least for your secrets you should do it. There is another key point here is that so you ran your cluster like a month and then you did this. Up to that point, whatever secret is created, it will still be unencrypted inside etcd. So after implementing this configuration, you have to recreate the secrets again, make sure that they are encrypted. And yeah, you should just tell API server about this configuration so that API server will be taking care of it. Another thing with etcd is that etcd stores the data in revisions. So if you run etcd control command, so let's say we have some key x, and we change its value over different revisions, you can still get previous revisions value from etcd as well. So again, if you do not run, I mean, even if you encrypt the secrets again with this encryption configuration, you can still access to the previous values. So you need to do some stuff on etcd side as well, especially for your backups. So we also made sure that etcd is, or our data, secret data on etcd is also encrypted. Again, what about secrets? So I would suggest to use Vault, or it could be any other solution. I mean, well, here I'm talking about some products, but that doesn't mean that you have to use those, but these are the ones that I prefer or mostly commonly used. But with HashiCorp Vault, what happens is that basically your pods connect to or communicate with the Vault server at the initialization of your pod and gets the secrets there, and then starts your application starts running. So that means there won't be any Kubernetes secret created within your cluster. There's also another project, Container Storage Interface, where you can basically, I mean, it used to be like the volume plugins were within the Kubernetes code in tree, but now they are now with CSI, third-party tools or storage providers are allowed. So you can also use volumes from outside and mount those as a secret store to your cluster. Last time I checked, this was like in beta stage or alpha stage, but and it wasn't supporting a lot of providers. But this is also a project to check for those kind of secrets. And again, here you just provide the secret provider class for your cluster, and then your secrets will be mounted as a volume from the secret provider. Yeah, I think right now there is support for AWS, Azure, GCP, and Vault. I suppose there will be more. You can also look at this one as well. So King Admin took care of some stuff already within the cluster, and then now he looks for some craftsmen, so he wants to get some additional help from other stuff, and he wants to do some static pod analysis and image scanning. So for static, so basically now Hakarius is trying to reach out to you or your CI or CI/CD pipelines. There's a project called kubesec, where if you provide your manifest, Kubernetes manifest or pod deployment manifest or the others, it will provide you some information about what is wrong with this configuration. So for example, here it says that there is the sysadmin capability in this pod given, or it is running as root, etc. So if you run this type of stuff within your CI/CD pipeline, I think it's a good practice to, especially if your teams are sending the manifests, let's say to do some GitOps, then you can do those kind of checks, and maybe you do not merge that code and make sure that they will not actually go to production. And even better, you should do some pod analysis via cron job or via what was the name? That Timo's tool. If you do such scans on your production servers, it's even better. And you should also do image scanning. There is a called Trivi. For example, if you check for Nginx, it just so by default it gives you lots of vulnerabilities which are actually maybe you cannot do anything. So it's also another discussion what you should do with the all vulnerabilities reported from your images, right? This is also an issue. So you can say that you can ignore the undefined one. You can define, you can ignore the unfixed ones. So if it's unfixed, you can't do anything. But of course, you need to take this risk. And it would come with that sort of stuff, or you can just say that, okay, only report me the critical severity issues, etc. There are some other tools. 3V is not the only one, but well, doesn't matter. I mean, you should do it. It could be any tool. Well, it's good to do it on your CI/CD pipeline, and it's even better if you do it on your production environment. So we also took care of this CI/CD stuff with static pod analysis and image scanning. And now the God Kyverno helps King Admin. Even if you have, so you might have, you might teach the people not to run your containers as root. You can put some stuff on your CI/CD pipeline, but still people can just start a pod as root user manually, right? So at some point you should do some forcing to people. And this is from Kubernetes documentation. The API server has 3 stages for the incoming request. So it does the authentication, then authorization, and then the admission control. And within the and then it actually writes changes to etcd. And with the admission control, you can do some webhooks, and you can do some mutations to the incoming, let's say, deployment, and also do some validations as well. So basically, for the incoming deployment, to the pod spec, you can just say that run as root no, or run as non-root yes. Don't remember the configuration. So you can just mutate things, put there, and then make sure that this deployment is running. We used to have pod security policy, but to make sure that, yeah, privilege are not allowed, or privilege escalation is not allowed or allowed, that sort of stuff. But this is deprecated in 121 and removed in 125, so you can't use PSP anymore with the latest releases. There's OPA. OPA is a more generic policy engine. It's not specific to Kubernetes. You can use it with Kubernetes, but you can use it all or in your environment on other products as well, where you define some rules, policies with a language called Rego. The downside I see about OPA is the Rego, because you need to learn a new language, and not only you, but your whole team and everything to update stuff. But this, I mean, it's not hard, but again, you need to learn new stuff, and you're just saying that if the image or the container image does not start myimageregister.com, then you just do not allow this container to run in your cluster. There's another project called Kyverno. It is Kubernetes native, so it is actually developed for Kubernetes, only Kubernetes. Does the same thing. It has the admission and also validation webhooks. So because it is more Kubernetes, like it's YAML. I'm not saying YAML is the best, but this configuration does the same thing. It makes sure that your container's image starts with my private registry. Of course, it's not only for that, but you can have lots of different policies. As I said, you can make sure that your pods does not run as root, or they are from a specific registry. There are many examples on Kyverno's site you should check out, and definitely implement some policies. So with Kyverno, we also secured API server, and there are some kernel gods that wants to back King Admin. I need to be a little bit faster. There's AppArmor. It's a mandatory access control framework. This, of course, because this is kernel, it's for Linux. It's not specific to Kubernetes, but it's for Linux and containers and the whole kernel stuff. Basically, you can whitelist or blacklist a program's access to an object. Could be a file, path, etc. There is a Linux security module, LSM, which is actually you configure it to make sure that some stuff on the kernel does not run or they are run based on the policy. And with AppArmor, you say that, okay, only allow this or do not allow that side as well. And in your container, you say that, okay, I want to use this AppArmor profile in my pod. There's also another thing called gvisor. It's a sandbox runtime. So with gvisor, gvisor provides some limited syscalls or just copies of those syscalls, and then do not allow your container to directly talk to the kernel, but a sandbox environment, so that the user cannot run some specific stuff. So we also secured the worker nodes with AppArmor and gvisor, and then KingAdmin starts monitoring. So, well, you should enable audit in your clusters, and but it might provide a lot of logs. So you should be checking on what resources and what kind of actions actually you are checking. But you should have some audit policy, and there are different stages for those. I think you should check the documentation how to enable it. But at least for reading secrets, deleting secrets, that sort of stuff should be audited in your cluster. And yeah, these are also regarding audits. And with the to enable audits in API server, yeah, basically you provide the audit file, where to log, and mean stage and max age and max size for your logs. So for monitoring, you have the audit logs, so you know who is doing what within your objects, to your objects within your Kubernetes cluster. There's Falco. You already got some information about it. I will not go into details, but Falco is great to detect some threats. If someone is, let's say, creating a shell inside a container, then it can just detect it and alert you. And after Falco, you should also do some benchmarking. Okay, you made some configuration, you have your cluster, but is it really configured correctly in terms of security? There is another tool from Aqua, Kubebench. It's actually based on CIS rules about Kubernetes. So when you run it, you will see a list of stuff saying that, okay, this file has wrong permissions, or you did not, you are allowing connections without authentication, etc. That sort of stuff. So it's also always good to get some report about your cluster. So again, KingAdmin with those, I mean, he got some proactive actions, and also he starts monitoring. Now he feels more secure about his kingdom. And if I go to summary again, you should have firewalls, you should have authentication and authorization of kubelet, and also, of course, Kube API server. You should have least privilege principle and set up RBAC. Having your containers read only like distroless images, or so with distroless images you don't have shell inside your container. So even if you, I mean, you basically cannot run a command inside this container, so it's a good practice whenever possible. Well, again, do not mount service account. Encrypt sensitive data. I mean, preferably do not have sensitive data in your Git repos. If you have to, then encrypt them. Make use of external secret store. It could be HashiCorp, Vault, or anything else. Use a service mesh. Could be Istio, could be Cilium. Doesn't matter. I mean, depends on your environment. On etcd, again, encrypt secrets at least. And on backups, there is no plain text secrets. Of course, also ensure that your backups are a safe place, so you don't put inside a S3 bucket and then this is open to public. Rotate this key. Try to have some smaller images, preferably distroless images, and definitely do not have sensitive information inside your container images. So when you create an application, do not put any user passwords inside the container itself. Try to read them from an external vault or some other place. Do static pod analysis, do image scanning, and do manifest static pod analysis and scanning. I mean, do also those things on your CI/CD pipeline. Kyverno with admission. I mean, not necessarily Kyverno. You can use OPA or whatever you have, but do make sure that you have some admission webhooks. You can have host-level security tools like AppArmor, have audit logs, use Falco, benchmark your cluster, and then, stuff that I think I already mentioned, you should have. Again, don't be this guy. do not forget this guy, and you know that this guy will always be around and try to do some stuff. Thank you very much for listening, and if you have any questions. Okay.
Where should we start?
I think,
I just have a small question. It's actually an opinion from you, I need, and that is, what's your opinion on signing images in the CI/CD pipeline? Does it have disadvantages? Or something?
I think I should also update my presentation. It's also a good practice to make sure that the container you are running is actually the one that you built. It's not coming from a untrusted resource. There is a project called SigStore, but I don't exactly know how it works or if it works with Kyverno. I know it's a different project and does some stuff to sign the containers, but you can check that one as well. Yeah. Or you have your registry within your organization, not public, and then with Kyverno you can say that, okay, I will allow only images from this repository. That's also possible, but still does not prevent people from within your organization to do some malicious stuff.
Hello. First of all, thanks for the talk. I think it was very good and
thanks.
very holistic. Everything was covered.
Thanks.
I wanted to extend on one point. Could you change to the slide with the admission controller with Kyverno?
Sure.
And I think that this will be interesting for a lot of people here.
Yeah.
Because since Kubernetes 1.23, there's not only the containers list of containers within a pod, there's also the list of init containers, which will start at the start. And since 1.23, there's ephemeral containers.
Yeah.
And these containers are usually not listed within admission controller rules. True. And during a recent penetration test, we managed to own the system because of that. So I just wanted to mention that.
Yeah, true. There is a new command called kubectl debug, which creates ephemeral containers, and it really makes sense also to check those.
And you can misuse that to bypass any rules within the admission control.
True. Yeah. Thank you very much. And there's one link behind.
Where was? Thank you for the nice talk.
Thanks.
In the summary, you had a lot of items what I should do.
Yeah.
Is it ordered by priority?
No. Yeah, just I think yeah, they should be done. I mean, it has different aspects, right? You should do monitoring in any case. I mean, even if you do not have any protection, you should be doing the monitoring so to understand what's going on within your cluster, right? But as well, so I've always worked as a operations person, like sysadmin or operations. I personally think monitoring is very important. I mean, it should be done in the first place when you have something on production, because if you don't have it on the first day, then it doesn't come for a long time. For my priority would be monitoring to see what's going on within your cluster. But yeah, maybe you don't have to implement AppArmor or gvisor, those kind of things. I mean, these are a bit more, it could be too much. But you should definitely have some policies. You should definitely do scanning. I mean, scanning is kind of monitoring and also like proactive action. Yeah, I mean, that's my personal opinion is about monitoring first, but you should definitely do at least some policies within your cluster to make sure that people cannot run containers as root, or do not run images from this or that repository, etc. That sort of stuff. Or yeah, like base images of Ubuntu 16.04. I mean, it's like too long ago. I mean, you should not allow those kind of stuff as well. So
Okay, thank you.
You're welcome. I don't know if it was a good answer for you, but it was satisfying. But
other questions? Hungry?
Yeah. I'm sorry, I took some of your time from your lunch.
Thank you very much, Koray,
thanks.
for your session.
Yeah, thanks.